All right, John. As I mentioned at the top of the show, OCP Summit happened last week, and there was a lot of news that was coming out. Some trends that were going on in the market, some of the larger things that we're seeing. And I figured it might be nice to kind of sit down and maybe take a closer look at some of those. One of the ones that really stood out to me, and it came courtesy of a news release from ARM, is that global data center energy consumption is expected to triple by 2030. So in just 5 short years, data center output power wise is going to be triple what it is today, which kind of tracks to some of the news stories that we've been reporting on the rundown, where we're seeing companies like Microsoft and Amazon
Hmm.
investing in small scale nuclear reactors. We're hearing that a lot of companies that are trying to say, we know, remember how we said we are going to be green and carbon neutral? Yeah, that's right out the window. Are we reaching a pace where this is unsustainable?
Yes, I think you're right. There's a major contradiction going on, right? In their pursuit of AI, these companies are going to be burning more energy than ever. And the one company in particular that stands out to me as one that's kind of caught in the crosshairs is NVIDIA. And in fact, I'll let you in on something. I don't know if it's become public yet, but NVIDIA is working on a new corporate blog. And within that corporate blog, they're going to talk about how they are socially conscious, or some of the things they're doing that are for good for society. And I think they're trying to get ahead of this problem because, in a sense, they will be as guilty as anybody for churning through energy. And that's, as you mentioned, an impetus for this interest among, let's say, Microsoft, Amazon, Google, in SMRs and in nuclear plants in particular, 3 Mile Island of all places. This is going to only accelerate because they need to find other sources of renewable energy that is somewhat clean.
One of the things that I think about when we come to this power situation in the data center is that it's unsustainable, but not for the reasons that everybody's thinking. The world's going to be able to come up with more power generation. Like, we know that if we have to turn on a couple more nuclear reactors to get that power back, great. If that means that we can actually do more research into fusion power, even better. Do you know why it's unsustainable? Because I have this tiny little needle that's going to pop that AI bubble pretty soon. And then all of that data center power generation that people are building up for is going to disappear. Yeah, I know that if you read any analyst report out there, AI is not going away. See also blockchain, see also software defined networking, see also .com. Do I need to keep going? Because that's 25 years worth of, oh my God, this is the best thing ever and it's completely sustainable forever. No, it's not. And that's the thing that people need to understand. Granted, we are going to have to ramp up this power. And like my friends over at the Packet Pushers said, these are the kinds of projects that take years to bring online. So all of the efforts that they're doing now to meet this growing demand, they have to start them now because they won't be ready in 5 years if we don't. So I feel like this is a reaction, and it's a positive reaction to what we're seeing in the industry, because everyone's like, well, why didn't we just start building out this stuff 3 years ago? Well, 3 years ago, OpenAI existed, but nobody knew who they were. And the real issue that we were running into was the fact that we needed to be able to power cloud data centers, not AI data centers. So I think that we're moving as quickly as we can, where the timelines on these projects are different. But don't be surprised if in 2028 or 2029, either the power consumption goes down significantly because we figured out how to make them more efficient, or maybe we don't need to get so totally crazy about that. Because one of the other things that you have to deal with is the fact that we're constantly improving the way that we do chipsets. And one of the things that came out from ARM is the insane amount of resource cost that it takes to miniaturize chipsets. Now, as everybody knows, the processes that make the chipsets are referred to by them the nanometer size of the components on the die. And so, some of the older chipsets are like in the dozens of nanometers. We're slowly kind of moving down. The current cutting edge technology, if you want to call it that, is 3 nanometer process. That's probably what your newest iPhone is running on, is a 3 nanometer. Going down to a 2 nanometer process is the next big jump. But according to the people at ARM, the design costs to move from a 3 nanometer process to a 2 nanometer process could top $725 million in order to be able to do that the way that we want to do that. So in addition to the fact that we're paying a buttload of money for power, we're also worried about the fact that moving these processes down into smaller and smaller scales is going to cost at this point, honestly, billions of dollars. I have to go back to the sustainability argument. John, is being able to spend this much money to make things a little faster and a little smaller really sustainable?
Yeah, that's the big question. And you mentioned this timeline. And for me, that's what it all comes down to is when does the bubble pop and when do all these companies that do exist now or are about to be launched go away by the wayside? Um, you can hear anything from 2 years to 5 years to even 7 years. So you have to balance the idea of what your needs are, what your budget is versus your own survivability. So I think, as you said, this will be mitigated somewhat by fallouts, and it won't be as crucial an issue, perhaps. And ironically, it won't be as crucial an issue because companies are going to fail.
Yeah, I'm kind of in the same boat that you are, John. I agree that we need to keep making things faster and faster. But much like Moore's law, we're going to hit a limit. Like there's only so much smaller that we can make these chips before we're going to waste so much material getting it working that we are basically cutting off our nose to spite our face. And everybody wants slightly smaller things, mostly. But as you've seen in the response to a lot of the new, consumer technology, there is a size limit. The iPhone Mini kind of flopped because nobody wanted it to be small. They wanted it to be the right size. It's Goldilocks, right? Too big, too small, just right. Um, but that also means that you're having to do other crazy things, like you have to miniaturize the chips. Why? Because you have to make the battery bigger. Because it turns out that people are spending more and more time on their devices. So you do have to fight these miniaturization battles. The problem is that you have to do so much other stuff to the facilities in order to be able to hit these targets that it is crazy. For example, did you know that you have to shock isolate these buildings in order to get high yields? Because traffic driving by on the road outside the facility can cause enough vibrations to ruin yields. It's one of the reasons why there's usually like a half a mile or more between the actual building itself and the main highways, is because they are so sensitive to these kinds of issues that they have to plan ahead. And that's part of what the 75, $725 million is going into, is figuring out how to build these facilities. And you want to try to build them in places that have earthquakes? Good luck. One of the other problems that you get when you miniaturize stuff that much is heat. And as everyone who took elementary physics knows, energy that isn't consumed is converted to heat. Also, ask anybody who's ever tried to overclock their PC and turned it into a very effective toaster oven. So one of the things that was really hot at OCP, pun fully intended, was the use of liquid cooling for devices. Now we've seen it kind of in the hobbyist scene, where instead of putting a big copper heatsink on top of your CPU, you circulate some kind of a cooling fluid, much like your air conditioner in your house, in order to keep things cool. But we're starting to see like rack scale liquid cooling solutions, or in some cases, as I saw from some of our great field day delegates that were there, the possibility of doing immersion cooling on some of these devices. So, John, is liquid cooling the future, or are we going to have to worry about bailing out our data centers with a mop and bucket?
I think you are dead on, Tom. It is in our future. I don't think we have much of a choice at this time, this point. The thing that really strikes me about, just in a larger sense, about what's going on in the tech industry right now is that we have so much hype, yet we have so much impatience, especially impatience among the investors and the C-suite. They want results now. They want to hurry up. They want to hurry up, but we have to sometimes wait and put in place some guardrails, literally guardrails, not just against digital enemies or attacks, but guardrails that apply to things like, I don't know, nuclear reactor, where human lives are at stake. I don't mean to be too cryptic. I don't want to go 3 Mile Island on you or China syndrome on you, but these are things that we have to consider. I mean, in a sense, we've escalated things to the point where we have to seriously consider all these options. We don't know when this market's going to take off, when it's going to crash. Who knows?
Well, I hope it doesn't crash like a giant tidal wave, because that would be awkward. But this is a problem we've known about for a very long time. And this kind of goes back to that whole we can only make things so small. Eventually, we're going to hit a limit where the things that we're doing are incapable of bleeding that heat. Heat is the enemy of everything. And I referenced Warhammer 40K in the opening, but anybody who's ever played BattleTech knows that you need more heat sinks on your mech if you're going to use the really cool stuff, right? Well, you can only sink so much heat. And the other problem is that in a lot of cases, that passive cooling capability just sits there if you're not using it, right? How often does your air conditioner run versus not run? Most people would say you don't want it to run constantly, but when you think about the way that these cooling systems work, you don't want them to run constantly. You want them to run at a high efficiency level, right? And so I can see this being a big boon for people. But the flip side of that is that we need to use more efficient technologies to build the servers in the first place. That's why things like silicon photonics are more exciting to me. Yeah, the stopgap right now is to put liquid cooling in a server because silicon photonics is still a couple of years away, if not more than that, in order at the scales that we need it. But eventually, the way to make this whole problem go away is not to continue to rely on copper, which is a really good conductor of electricity and a really good producer of heat. It's to create systems that don't generate as much heat in the first place. And I think that that's one of the lessons that we can learn from OCP. Power costs are always going to go up, chip sizes are always going to go down, and no matter what, they're always going to produce byproducts that we don't want. So we need to figure out how we can build better systems. And maybe the answer isn't to just chase the almighty dollar, but to figure out what's going on that we need to be better about. We need to make these things more responsible. And I hope that some people are paying attention to that.